Welcome back to Triptych Algebra. Today we're talking about absolute value inequalities. Absolute value inequalities are super important, difficult concepts in early algebra, but applicable through all sciences. I'm going to start with two examples. The absolute value of x is less than 4, and the absolute value of x is greater than 6. We need to know what we're doing. What are we doing when we're solving these inequalities? What we're doing is we're finding the values for x that satisfy both these inequalities. In this first example right here, I'm looking for numbers that I can plug in so that the absolute value is less than 4. I want to make that very clear. These numbers must have a small absolute value of less than 4. In this example right here, we're very similar but opposite. We're looking for the values that we plug in so that the absolute value is greater than 6. So these have what I would call large absolute values of greater than 6. And what I want to highlight right now are how the solution sets to these two inequalities differ pretty significantly. Which numbers have an absolute value of less than 4? Well, these are very small numbers. Small positive and actually small negative. For instance, the absolute value of 3 would work. The absolute value of 3 is 3, that's less than 4, but the absolute value of negative 3 also works. So in fact, all of the numbers from 0 to 4 work, and all of the numbers from 0 to negative 4, though numbers like negative 5 would not work. Negative 5 is not a solution to this because when you plug in a negative 5 and then take the absolute value, you actually get a value out bigger than 4. So we're limited to the numbers between negative 4 and 4. As an inequality, it would look like this. As an interval, it would look like this, in interval notation. For numbers that have an absolute value of greater than 6, these are large numbers. So in fact, in this case, on the number line, I'm looking for numbers that are bigger than positive 6. And now if I'm considering negative values, I need negative values that have an absolute value of larger than 6. And in fact, like negative 7, negative 8, negative 100, very small negative numbers have an absolute value of greater than 6. And so visually, it would look like this right here. As an inequality, these are two disjoint sets. The numbers less than negative 6. In this case right here, I have the numbers greater than 6. As an interval, I would write these two disjoint sets like this. These are the numbers less than negative 6, and these are the numbers greater than 6 right there. The big difference between these two is the greater than or the less than. It has nothing specifically to do with these numbers, though they do play their part. In this case, if an expression, absolute valued expression, is less than a positive number, that expression needs to be between negative 4 in this case and positive 4. In this case right here, when I have the absolute value is greater than a number, I'm not looking for numbers confined around 0. I have these disjoint sets right here. Numbers that are greater than 6, those work, but then numbers that are less than negative 6. Let's look at a couple examples that are very similar to these, but add expressions on the inside here, and let's see how that works. But again, try to keep these concepts together of less than absolute values and the greater than absolute values. All right, now we have two examples very similar. The only difference is I've put in an expression inside the absolute value. In fact, I've put the same expression in both of these just to show that the only difference between how we tack these is the way that this absolute value or this greater than or less than sign is facing in terms of the absolute value. I need this expression on the inside. Now this time, it's the entire 2x plus 4. I need that 2x plus 4 to have an absolute value of less than 4. So now, if you think back what I had a second ago, 2x plus 4, as said before, I need this to be either less than 4 or I need it to be greater than negative 4, sandwiched in between negative 4 and 4. In this case, the 2x plus 4 is greater, the absolute value of 2x plus 4 is greater than 6, meaning the absolute value of whatever comes out of this expression right here needs to be greater than 6. Well, I have these two things. I have that 2x plus 4 has to be less than negative 6, as before, right? This has to output something like negative 7. Or I need this 2x plus 4 to be greater than 6. All I'm doing is saying the expression inside the absolute value here is sandwiched in between negative 4 and 4 for a less than absolute value. For a greater than absolute value, what I'm saying is the expression on the inside of the absolute value has to output something that's less than negative 6, so that when I take the absolute value, I get something bigger than 6. Or this expression needs to output something that's simply greater than 6 right here. Let's solve these real quick, get the solutions set and compare them, and say some final words. To solve this compound inequality, what I'm going to do is subtract 4 from all 3 parts of this inequality. I'm subtracting 4 because my goal is to isolate this x right here. What I'll get is negative 8 is less than 2x now, though that cancels with that, is less than 4 minus 4 is 0. Divide everything by 2. And what I'll get, I'll put my solution set over here. That divided by 2 is a negative 4. The negative, or the 2's cancel each other out to get an x, and then 0 divided by 2 is just 0. This is my answer as an inequality. In interval notation, this would be negative 4 to 0. Techniques, I'm going to subtract 4 from both sides of these equations. Getting 2x is less than negative 10. And in this case right here, I get 2x is greater than 2. Divide both sides of these equations by 2. Solutions for these up over here, because where I got room. This would give me x is less than negative 5. And then this statement right here would be that x is greater than 1. Then this is the inequality answer. In interval notation, the numbers less than negative 5 would be written like this. The numbers greater than 1 would be 1 to infinity. Again, really importantly is how these final answers look. That's something that can really help you as you move forward and try to get better at these, is that the less than absolute value inequalities have contained intervals, like one solid interval in this case, contained within the negative and positive of this constant right here. For greater than absolute value inequalities, we're always going to get these disjoint sets that are less than or greater than the negative and then positive, respectively, values of this constant right here, where this 2x plus 4 is less than a negative 6, or the 2x plus 4 is greater than 6.